Hi there, welcome to Miss B's Math Academy. I'm Nina Benazar and I am the creator and founder of Miss B's Math Academy. I'm also a certified 6-12 math instructor. In this video, we're going to learn about
systems of equations, and the first lesson we're gonna talk about today is going to be solve systems of equations by graphing. So, what is a system of equation? A system of equations is a collection or set of two or more equations. Example, think about two equations from your bellwork. Each of these equations have infinite number of solutions as shown by the graph. Every dot on that line is a solution to that equation. So, what is a solution to a system? We know each equation in a system has infinitely number of solutions individually. Okay, so every line has infinitely many solutions because again, each point on that line is a solution to that equation. Now, when we consider the equations together, they become a system. When finding the solution of a system, we're looking for the pair of values that satisfy both equations, not only one, but both equations. So think about how many times do these two equations intersect? How many solutions does this system have? Well, if you look at this, the only time where they will cross is in that point right there. That's the only point that will make both solutions, both equations true. Okay, that's the only place, that's the only common place that both equations have. So again, what is a system of equation? If we put both graphs on one coordinate plane, okay, and consider them together as a set, they become a system of linear equation. What do you think is the solution to the system? One more time. It's the point where the line crosses. The point where the line crosses is the only point, the order pair x and y value, that will make both equations true. Okay, so the solution to a system of linear equation is the point where the lines intersect. In this case, it's -2 and 2. This point will satisfy both equations. So let's prove and see if it actually satisfies. Well, we're saying the first one is -2 is x and y is 2. So I'm going to change my equation right here and do the math. And we get -6 equals -6. And that is a true statement. And then we try it for the second one. Repeat the same process again. We're just plugging in the x and the y values. And we're going to get -10 equals -10, which is a true statement. So again, this is the only point that will make both equations true, that will satisfy both equations. All right, so solving system of equations, example 2, we're going to identify the solution to each system below as a coordinate point. Explain your reasoning for each answer, okay? So for A, we talked about that the system of equation, the solution to a system is where they intersect. So we can see that this graph A only have one place where they meet. So it's only a one solution. And the solution to this system per se is going to be 3 on x and -3 on y. So that's the solution to that system. Okay, we have an x value, we have a y value. We're always going to have an order pair as a solution to the system. Okay, now example B is a little bit different. What do you notice about example B? Well, those are what type of lines? They're parallel lines. Parallel lines never intersect. They will never cross. Okay, so this system is said to have no solution because they will never cross. They will never intersect. Okay, so therefore there's no point. There's no coordinate point that will satisfy both equations. Okay, example C. Again, you can tell they're crossing at one point right there, so it's a one solution. And the solution is going to be x is -1 and y is going to be 3. And then on D, notice that there's more than one line there. There's actually 2 lines there for you, okay? So that means that every point on one line is a solution to the other one because the line is on top of each other. They're essentially the same line. So this one has infinitely many solutions. All right. So a very little summary right here. The graph of linear equations in a system can intersect at 0, so meaning no solution at one place or infinitely many places, okay? So again, no solutions will be parallel lines. They don't intersect. It will give you a false statement if you're doing the math, okay? You will end up with something that is false, just like before. A one solution, again, you have one solution. They will intersect one place in the graph. And it will have a unique value for each variable. So the x will be a point and the y will be a different point. They could be the same numbers, but each variable you will be able to solve for x and we'll be able to solve for y, and when you put them together, they will satisfy the equation. Infinite many solution is infinitely many. It's essentially the same graph, the same line, and it's gonna give you a true statement. So 12 equals 12, or negative 1.56 equals negative 1.56, or 0 equals 0. It just gives you something that is true, okay? Moving on. System of equations. Now we have a word problem right here. Solve the system of equations by graphing. When we're solving system, there's three methods we're gonna learn. The first one we're learning is graphing. This is not the best accurate one because when you're graphing, you can make mistakes. So it's not the most accurate one. But if it gives it to you with a graph, you can find the answers. We're gonna learn two other methods later during this unit, and that's going to be solving by substitution and solving by elimination. The word problem right here says solve the system equations by graphing. So basically what we're gonna do, before I read the word problem to you, I know I'm gonna be graphing these two lines, and I'm gonna see where they intersect to find the answer, okay? So Scott recorded the temperatures in two Alaskan cities, Anchorage and Wasilla, and I'm sorry if I'm pronouncing that wrong. The temperature in Anchorage was negative 3 degrees Celsius, increasing at a rate of 1/3 Celsius per day. In Wasilla, the temperature was 1 degree Celsius, decreasing at a rate of 1 Celsius per day. The system below represents the temperature in the cities, where X represents the number of days and Y represents the temperature. So we know the X value is the days and the Y values is the temperature. So we have two equations, okay? And I'm gonna do the same colors. So the purple one, I'm gonna do it for you. We know the initial value is -3, so we're gonna start the y-axis at -3. And we know the rate of change, or the slope, is 1/3. So I'm gonna go 1 up and 3 to the right. So this is a quick review on how to graph in case you forgot, okay? Going up 1 and 3 to the right. Once I have my 2 points, I'm gonna go ahead and connect my line, okay? So that's my first line. That is for Anchorage, okay? Now we're gonna do the second city, Wasilla, or whatever I pronounce them. Again, I'm sorry if I mispronounce it. And this one, I'm gonna do it in blue. So the initial value for this one is going to be 1. So I'm gonna start at 1 on the y value, on the y-axis. And my slope is -1/1, so that means I'm going down 1 and 1 to the right. And I repeat the process 2 times just to have several points. Now I'm gonna connect them, and those are my 2 lines, okay? So remember that the solution to a system is the point where they meet together. So that's that right there in the middle, okay? And I have my 2 questions that I need to answer, okay? And that's my point. My point is going to be 3 on X and -2 on Y, okay? So now let's think about that means. We know the question says, on which day will the temperature in both cities be the same? Well, the day is given to us by the x-axis, so that's the x value. So that means both cities will have the same temperature on the 3rd day, or on day 3, okay? And then what will the temperature be on that day? Well, the temperature is given to us by the y-axis, so the y value is -2 for that point, so the temperature will be -2 degrees Celsius. And this is it for the lesson.
Thanks for watching Miss B's Math Academy, and I'll see you next time. Remember, the best way to learn math is by trying on your own. So practice, practice, practice.